Okay, so we're moving on from expressions to equations. Now, when we look at the word equation, what do we hear?
Equal.
Equal, very good. So an equation is a mathematical sentence that shows expressions. Let me go down. Yes. She's on her way. Are equal. Now, the thing about this, okay, I'll swap you mine, and you can have this, okay, because it's already filled out. A mathematical sentence that shows expressions are equal. And the thing about this, I heard somebody say it a second ago, we must have an equal sign. Okay, must have an equal sign. So where last week and the week before we were writing expressions, but they weren't equal to anything, this week we're actually making them equal to something. And we'll see what we do because we can actually solve them now.
No.
Yes.
No.
All right, so the word solution. What does the word solution mean? Just like in everyday life. What does it mean?
The answer to a problem.
We're fixing a problem. It's the answer to a problem. So solution for algebra is going to be the value of the variable. The value of the variable that makes the expression true. Now, when we have a solution, it will be written with a variable, an equal sign, and your number. Now, it could say 7 equals x or x equals 7 either way, but you won't just have the number 7. Okay? You will have something variable-wise equal to your solution. All right, what about the word solve? To fix it, okay? So we're going to say that we are finding the solution, which we just figured out was the value of the variable of an equation. And that's what we're going to do today. We're actually going to solve equations. All of our work with expressions and variables and all that stuff is leading up to this, guys. You're fine. Okay? And our word for the day, when we solve an equation, is going to be isolate. We're going to isolate the variable. If you isolate something, what does that mean you do? You leave it. Very good. Say it again. Put it by itself. So that's our goal, is we want our variable by itself. Okay? We want it on one side of the equal sign with nothing else. And we're going to do that by using something we call, and this sounds more complicated than it is, the inverse operation. What does that word inverse mean?
Backwards?
Well, backwards or opposite, okay? So I like to use the word opposite. So we're looking at the opposite operation. What would be my inverse operation of subtraction? Addition. And therefore, the inverse of addition is subtraction. Okay? And that, sorry, those are the two we're going to focus on today, is addition and subtraction. Okay? That's right. There you go. So, here we go. Looking at the first example. Again, my goal is to isolate the variable. So I want to get rid of something here. What do I want to get rid of? 3.82. And I'm going to do that by using the inverse operation. So this is addition, and I'm going to do what? Subtract. So what I'm going to do is minus 3.82. Now, on the playground, have you ever seen seesaw, teeter-totter, whatever you want to call it, where people sit on opposite ends and you try to balance, but usually it ends up like, you'll push your feet off really hard and your friend will hit the ground. Okay? Well, we want to keep it balanced. Our goal is to keep it balanced. So our equal sign is right in the middle here. So if we do one thing to one side of our equation, what do we have to do to the other? The exact same thing. So if I did minus 0.382 over here, I had to do minus, whoops, sorry, 3.82. I'll get it right. All right, now, if I look at this, and let's say this is $3.82, and I subtract $3.82, what do I have?
0.
And the identity property tells me that x plus 0 equals x. So these just cancel each other out. And yes, I want you to show every little step, just like I'm doing. And the reason I'm doing that is, guys, this is the bottom floor of algebra. We are on the ground floor. These are one-step equations. You eventually one day will get to 3- and 4-step equations. So you have to do and show each step like this so that when it does get more difficult, you know what you're doing. Yes?
So
Why are we doing?
why do we have to put the number down there?
Because this is actually a rule, okay? This is called the inverse. It's there's actually a property basically that says it will undo. So we have got to show that we use the inverse operation to solve it.
So that's
You have to show this.
Why did you put the second?
I'm not there. I'm not done yet. Just give me a second. We have to show, well, and for you guys, the words y'all want to hear, if you don't show this, I will mark it wrong. You have to show this. Because like I said, this is just the beginning. Okay? I'm teaching you the basic fundamentals, and as you continue going on, it's just not Miss Willis being mean. It's not your 6th grade math teachers being mean, making you show work. Guys, it'll be this way the rest of your school career. Yes?
I have no idea what you just did.
Well, hang tight. I'm not done. Okay. Guys, look at this. I have positive 3.82 minus 3.82. That gives me what? 0. Well, we said x plus 0 equals. What I want to do is get rid of what's on this side with my variable. I want x by itself. Now I can say 5.1 minus 3.82. And what do we get?
No, we get whatever number we subtracted.
No?
So is x 5.1?
Almost. No?
We get,
It's 5.10 minus 3.82.
it would be 1.28.
1.28. Okay? So this would be our solution. That is the value of our variable. And we find that by undoing what's on the same side with the variable. Okay? Now, the next thing we're going to do is check this. And yes, you have to check every problem. So, I'm going to go back to our days of expressions, and I'm going to plug this value in for x. So, if I see x up here, I'm going to put 1.28 plus, this is 3.82, is equal to 5.1. Now, if I have scratch paper, I can come over here and say 1.28 plus 3.82. This becomes 10, 11, 5. Is it equal?
Yes.
So 5 and 1/10 is the same as 5 and 1/10.
That makes no sense.
Yeah, if you put the 0, that's fine.
It's like both of them are equal.
Absolutely. I want both sides of that equal sign to equal the same amount. That's all I'm doing is checking to make sure that the solution I came up with makes them equal. Okay, let's try another. Try another. Okay, here we go. I have an addition equation. How do I undo an addition equation? Subtract. What number do I want to get rid of?
18.
Because 18 is what is with my variable. So I'm going to do minus 18 to both sides. This cancels this one out because 18 minus 18 is 0. So that leaves y by itself. Now I want to know what 72 minus 18 is. 54. So y is equal to 54.
Wouldn't it just be easier to just say 18 plus?
Understand? No. This is the conversation we had 5 minutes ago. I need you with me. You can't do that. This is the bottom floor of algebra. You have to show it this way. You have to show canceling out the number that is with your variable. Guys, you will thank me next year. You may think I'm being a meanie right now, but you're going to thank me next year when you're in the habit of doing this and your 7th grade math teacher tells you you have to show every step. You're going to be like, oh, no problem. We did that last year. This is not anything that's going to change. You have to show every step. Because the whole thing you're learning is algebraic thinking, as in undoing what's with your variable by using the inverse operation. Okay? So now let's plug it in to check it. We have 72 is equal to 18 plus 54. And if I look at this and I do 18 and 54, that's 12, 72. So yes, look, here's the great thing. By checking it, you should know every time if your answer is correct. Because what happens if I don't get the same number here? This one's wrong. I need to go back and check.
So with number 3, you would want to get rid of 1 and 5 cents.
Yeah. You want to get rid of whatever is with your variable. So, and I don't know if you heard me when I said this earlier. If you don't show it this way, guys, I will take off points. Because I'm trying to train you to show it the way that you're going to be expected to show it from here on out. Okay? So, we're getting rid of the 1.5. How are we doing that? Subtraction. It's the inverse operation. So that cancels that out. N is equal to 9.8 minus 1.5. What do we get? 8.3. So that is my solution. And now I can plug it in to check. So now if I look at this and I say, whoops, sorry, I didn't mean to cover that up. Let me come over here. So now I have 8.3 plus 1.5, that's 8, 9, 9.8. They are equal. And again, that last part's just to make sure that your solution that you found works for the equation. Yes?
I did it right here and didn't write. Is that technically wrong?
To check it? Yeah, I want you to plug it in. Go ahead, like show me right here where you plugged it in. Yeah. All right. Now, looking at number 4, this is not an addition equation. What is this? Subtraction. So we're going to undo it by addition. What number do I want to get rid of? 2. So I'm going to do plus 2 to both sides. W equals. Guys, look at this. 9 plus 2. 9 plus 2. 11. We got to wake up here. Okay. So now I can come plug it in. W is 11, so 11 minus 2 equals 9. And we should mentally know that 9 is the correct answer. So 11 is your solution. Make sure you're getting these copied down. These will be great examples for homework.
Would 11 be your solution, or would W equals 11 be your solution?
Excellent job. Yes, W equals 11 is your solution. Yeah. All right, I'm going to freeze this. Well, no, I'm not going to freeze it, but I'm going to give you a second. I'm going to cover mine up. I want you to, I don't want to freeze it because that'll mess up recording, but I'm going to cover mine up. I want y'all to work number 5, and then we'll check it in just a second, okay? So you try number 5 real quick. I'm going to cover mine up. Make sure you're checking it too, okay? When you think you got it, just look up here at me so I'll know when we can check. I'm seeing lots of pupils. All right, we ready to check it? Okay, I'll give you just another second. Answer is loading.
Oh. Why did you write that?
I just wrote loading. Huh?
That's what I wrote that.
I thought about doing loading or, what is it? 3 hours later. Okay, here we go. Let's take a look at it. So, we undo it with addition. So, F would be equal to 101 because we're adding 17 to both sides. So then 84, we plug it in to check it. 84 is equal to 101 minus 17, which, yes, that would be 84. And hopefully, if you didn't get the same one, you might have, like, a light bulb may have clicked when you checked it that it wasn't equal. Yes.
Is it okay because you put 101 equals?
Oh,
Could I put F?
That's perfectly fine. Yeah, if you put your variable first, that's fine. And eventually that will be the way we want it, is your variable on the left side, but it's okay for right now. So, yeah. And I can, as long as they're equal, I can flip them back and forth. Yeah.
Like 17?
Okay, so here we go. Looking at number 6. Again, it's a subtraction equation, so how do I solve it? Addition. What number do I want to get rid of? 1/2. So I'm going to add 1/2 to both sides. And this is where I realize that our fraction brains have abandoned us.
Oh, we have to. It's
No, don't keep change flip. That's division.
No, it's fraction.
No, I add 1. Yeah, this is 1/2. But that's minus 1/2 plus 1/2.
Is it 3/10? No, you make it 10.
Because this is subtraction. Right. So that would be like negative half plus a half. Because remember, the sign precedes the term. Okay, what is it? 9/10. Very good. Okay. This is one of those that would have been easy enough, guys. You could have gone and done the butterfly. Or make them equivalent denominators. So 5/10 plus 4/10 would equal 9/10. Okay. 1/2 plus 2/5. We have to have common denominators. So if I plug this in, this will be 9/10. Hey, what is 1/2 as tenths? 5/10. I'm going to go ahead and change that so I know I can check it. What is 2/5? Well, let's don't do that yet. Let's do 2/5. So this would be 4/10, which is simplified to 2/5. So yes, they are equivalent. So your solution is x equals 9/10. Yes?
Isn't 9/10 and minus 5/10
Yes, but 4/10 simplified is 2/5.
I did not. I was thinking for some reason the 2/5 was 1/10. I completely.
Okay, let's look at the bottom word problems. And to make you feel better, you don't have any word problems tonight for homework. We're just going to be practicing getting in the habit of this.
No.
But let's go ahead and talk through these. Jeff is 48 years old. This is 5 years older than Seth. Write and solve an addition equation to find out Seth's age. What do we not know? Okay, so I'm going to say A is equal to Seth's age. All right, and we're doing an addition equation, so Seth's age plus what?
40. Minus 48.
It's going to be minus 48.
Plus. Guys, we're doing addition equation plus 25. Thank you. Equals 48. Now to solve it, or to evaluate it, we're going to do the inverse operation of addition, which is subtraction. So minus 25 to both sides. This cancels out. So what is Seth's age equal? 23. Okay? And then I can go plug it in to check it. 23 plus 25 equals 48, which that is true. Be careful because, guys, this one said to do it with an addition equation. Just like the next one. The next one, I'll be honest, was hard for me. I kind of had to wrap my brain around it because it's wanting us to write it as a subtraction equation. So looking at number 2, brownies have to cook 28 minutes longer than sugar cookies. A batch of cookies takes 7 minutes to bake. Write and solve a subtraction equation to find out how long the brownies have to cook. What do we not know? How long the brownies? Well, we know the sugar cookies take 7 minutes. I know, you could, but what it's wanting you to do is train your brain to think algebraically. Guys, understand, we're giving you easy problems right now because right now we're training, these are the training wheels on your brain. Okay? One day we're taking the training wheels off and you're going to be doing harder stuff, but you got to have these basics to be able to do it. So we got brownies minus what?
Minus fraction.
28, because we know the cookies take 7. So this is a subtraction equation. How do I undo it?
28.
Add 28. That cancels that one out, so the brownies will take
35 minutes.
So then if I plug this in, and that equals 7. All right, I'm going to stop this right here real quick.